There was nothing there that was all that great. Let me see. All right, where did I put you at? Dude, there you are. Yay. Okay, so let me do this. Okay. Do you guys see in red, the hypothesis worksheet we started working on? Is this the one you're talking about, Lanja? Can you guys see that? Okay, you guys can see it. I'm guessing this might be the one you're talking about, Lanja. We're working on this together, so it's not due. That's for sure. I'm gonna look this way because I got another monitor and that's where you guys are. And then this monitor, I've got this thing, this worksheet. Ooh, Jeff got 2 monitors, yeah, all right. So we got this far. Let's kind of remember what we did. And please, dear God, I'm gonna try to keep an eye on the chat. Just let me know if something is freaking you out, right? And you're like, I'm freaked out already before we started. So we read through this problem. All right, we did this problem already up here. We did that one, we finished it and everything. So if you missed out, you can go back and watch that. So here we read through this and we saw that the claim was right here. Test the claim. Whoop, is the same. So that's the claim that the proportion is the same as the 84.5. And that's where this, I love it when I'm pointing at the screen for you guys. Sorry. That's the P equal 0.845. Okay. So obviously then, this is going to be so weird. I don't know. Obviously then that's got to go in for HO, right? Because it's got an equal sign. Okay. And then, okay, here's more people. So then the other one's going to be the opposite. So you got to let me know when I hit something that doesn't sound right or you need a refresher on, right? But everybody should know now the HO's got to have an equal sign. Since our claim has an equal sign, we put it in HO. The other one, whatever's left blank, is the opposite of that. So H1 is not equal to. And that's why we figured out it's a two-tailed test. Because not equal to could be up or down. It could be more or less. Okay. Then we checked to make sure it's normal enough. So of course we had to check NP and NQ. And they both came out to be at least 5. So that means yes, it's normal enough. So then therefore we can use z-scores. We only ever use z-scores if it's normal enough. And what really kicks ass, let me stop sharing for a second. I'm over there now. This is, I don't know if I'm going to use, let me turn off, I don't know if anybody knows what my background is, but you turn it off, whatever the hell it is. Got some time travel stuff back there. Okay. Oh. Okay. So now watch this. This is kind of neat. Oh, this is going to be so weird for me to get used to. Okay. Got some markers. Let's see if they work. We know these formulas here, right? That formula should look desperately familiar. That formula should look desperately familiar, right? And these are the ones, if I wrote better, you could really see this. But remember, this is what reminds you that I use Z if I know sigma, I use T if I know S. And of course, it has to be normal behind all of that. Oh, thanks, Chris. Yes, that's right. How many formulas are there for P, for percentage confidence intervals? There's just one. So for percentages, it's Z or nothing. And again, how do you remember that? These formulas tell you. They tell you so much. All right, I'll stop being all dramatic, at least for a moment. All right. So that's kind of nice. So it's for a percentage problem, I'm going to try to look at the camera instead of there. For a percentage problem, it's either NP and NQ do what they're supposed to do, so you can use z-scores, or one of them or both of them don't, and you can't do anything. Okay. So coming back to this thing. Where's my share? It's over there. Dadgummit. I don't know if I'm going to like this. I'm going to pop this back over here. And you're all like, just do what you got to do. All right, give me a second. All right, this I think will be better. Share, pop. All right. Yeah, I like this better. So now we're back to the sheet. And again, just let me know if you have questions, please, dear God. Come over here, come over here. Okay. You can see the sheet again, right? Hopefully. Let's see. The rejection region, we knew it was two tails from the beginning, right? Two tails. We know that alpha is 0.10. Dadgummit. You're going to let me do this. So we know alpha is 0.10. We know it's two tails. So then we can find the z-score. We look it up on the t-score chart because we're a little crazy. But we also remember that z-scores live at the bottom of that chart. So two tail, 0.10, go all the way to the bottom. That's where we got the 1645 from. Okay. And this problem is so, I know it's frustrating for you guys. I really do. It's a lot of steps. It's kind of like, my God, I'm not used to any of this shit. It's so easy to forget. The basic idea is, and I know I've said this before, the HO thinks it's in here. So if I get out here, if I get far enough away, and that's what step C defines, what's far enough away, then it looks like whoever thinks it's in here is wrong. And that's why we call these the rejection region, because I'll reject the null hypothesis if I get way the shit out there because he thought it was in the middle. It really is that simple. It's that. That's it. That's behind all these steps and all these details. That's what's behind the whole damn thing. It's kind of crazy. Okay. So look at step D here. Let's summarize a few things and then I'll let you guys do this step. So N is 322. X, get out of here. What was it, 282? I believe. All right. All right. So you guys do that. Finish that step up. I'll catch up to you. I'll just sit here and stare at you. The few of you I can see. I'll stop. It's got to be annoying. Let's see. Oh, shit. All right, let me catch up to you guys a little bit. We figured out what p hat is. .876, kick ass. Remember, you got to round those to at least 3 places. So Hannah, it would be 8758, but you could use 4 places if you wanted to. That's nice. It's got to be at least 3 places, remember. So then I can plug all this stuff in here. P hat, so my data, it's always my data minus what we're assuming to be the real middle, which is always the 0.845, the number that comes from the claim, 0.845, divided by the square root of all this shit. So it's P, 845, times Q, which is 1 minus that, right? It's going to be, can you be consistent, Jeff? I don't know. I'll think about it. Times 0.155 divided by 322. That's, oh my gosh, Jeff. What are you doing, buddy? All right. So go ahead and try to see what you get from all that business. I got kicked out. Okay. That's all right. So if you get kicked out and have to come back in, I'll see you. I'll let you back in. I can completely understand about internet instability. 0.845. I don't know. Oops, shit. All right, so anybody got that? I think I do. All right. So here's what it looks like in the calculator. You got to make sure that the top is in parentheses, and you got to make sure that all the stuff is under the square root. Right? Okay, just in case you had any issues there, but I agree with you. 0.15, I'm sorry, 1.54. Oh, shit and a half. There we go. 1.54, that's Z star. Somebody find the p-value, please. This is going to be interesting. Let's see. I can't remember if I told you guys about two-tail tests, what happens. If you forgot what the p-value is, just hang out for a minute. I don't even know where my chart went. Man, there it is. What are you doing down there? Come here. Okay. Look at you guys go. Oh man, that's so funny. Some of you guys sending it to me privately. All right. Let me see if I agree. That sounds right. Sounds familiar. 1.54. It's 0.9382. 1 minus that is 0.06. I just lost it. 0618. And then you double it because it's a two-tail test. I like it. So the p-value is the area in the tail or tails your Z-star makes. The same way that alpha is in the area of the rejection region tail. Alpha and p-value are the same physical idea. They're just tails of different z-scores. So yes, 0.12, so the p-value. So again, let me plot 1.54. Here's 1.54 is like right here. Oh my gosh, pretend like that line is straight. Oh my gosh, just please let me do this. Please. Go back. Stop it. All right. Sorry. Oh, man. Just give me my freaking whiteboard back. All right. Let me try this again. Move back. Thank you. Let me do a little star. Just let me do it. Just let me do a little star here. Just let me do it. No. Let me do a little star. All right. All right. All right. So the p-value is the area in the tail or tails that your Z-star makes. So the p-value is actually going to be like that. We double it just to make it fair because it's a two-tail test. So the p-value comes out to be, what was it, 0.1236? What did you guys say? Now, real quick, I already know. Look at the green line. Did we reject the null or did we fail? We already know the answer. Yeah, we failed. We didn't make it in. Is the p-value smaller than alpha? No. That's another way to tell you fail. The p-value must be smaller than alpha in order to succeed, in order to reject the null. Now watch. Oh, God. All right. This problem, this is some extra little conceptual stuff, but it's important. Where on the picture there, that really colorful picture, where is alpha? There's kind of an easy way to answer that question visually. Where is alpha? Outer edge, I like it. Malachi. The outer limits. The red scribbles. Parts of the shade. Kick ass. All right, the red shaded outer limits. Do not adjust your TV. So that area is the probability that the mean is, let me say this again. That area is the probability that we would get a sample in that area if the mean is correct. Right? So there's a chance the mean is correct. What is the probability that the null is right, even if we reject it? So if I, how do I say this? This is a bad example for this, but oh well. I'm trying to connect for you what I said earlier, that alpha is the probability of a type 1 error. Type 1 error is when I reject a true null, right? That's what that is. So if the null is true, there's still a chance I'll get in the red area. What's the probability of that happening? Alpha. So that's what I mean. That's alpha is the probability of a type 1 error. So to make a type 1 error less likely, you decrease alpha. I'll stop now because that's not as immediately important as the other stuff we're going to do. Okay. So the p-value is the area of the tail your z-star makes. If it's a two-tail test, you double that area just to make it fair for comparison. All right, so what can I put right here? The little tiny conclusion. That's not a full paragraph. Like you said, somebody told me we didn't make it in there. So we fail to reject the null. The hop? Sure, Jeff. So we fail to support the hip. I like that, the hop and the hip, hippity hop. Now I got freaking chickadee China, the Chinese chicken. All right. So to do my conclusion, my conclusion has to reference the claim. Yeah. My conclusion has to reference the claim. Which one was my claim? The ho or the high? Which one was the claim? The ho. What are you calling me? Oh, yeah, you're answering the question. So I must use this language. There is zero guessing, zero ambiguity about what language to use. You use the language associated with what the claim was, because your answer's got to be about what happened to the claim. Did we make it far enough to say it looks like the null is wrong? No. So of course we have not found evidence to reject the null. So here's a way, that's how you remember it. I have to use this language. Fail. We have not found sufficient evidence. Good Lord, Jeff. To reject the claim. That, what's the word of the day, kids? Plagiarize. Let me see. That's where to go. The proportion of students is the same as 84.5%. That's fine. Okay. So please, dear God, if your conclusion has nothing to do with physically what the problem is about, you're wrong. You've got to put in there what the hell the problem was about, right? Don't just say we have found evidence to say it looks okay. No, what? What? No, we found evidence to support things. Stop. What? All right, please. All right, thank you. Any questions on that problem that we have now finished? Okay, so what I want you guys to do, hopefully, all right, let me switch this over. Where's the one I want? That is the one I want. This is so exciting, watching Jeff figure out what the shit's going on. Hold on. There we go. I got you now. Do you guys see a problem up on the screen? Yes, okay. So it's the 918, try it. The marketers, blah, blah, blah. All right, let's do this. Read through that problem. Blah, blah. Don't worry about their bullshit, right? We know the 5 steps we got to do. And I'll tell you the 5 steps. So the first step, I want you to write down what the claim is and then write down what the hypotheses are. Please. Oh, where's my eraser? There you are. I think I'm gonna this way. Elevate. Oh shit! Almost knocked everything over. That would have been bad. Standing up now, you can see my mathematically related shirt. Okay. All right, guys. So, oh, shit. There we go. It's just a technically challenged morning. All right, leave me alone. All right, hopefully you got enough stuff written down. I'll put some stuff up here on the board. So hopefully you got the first step done. Okay. So, can somebody tell me what the claim is? Can you guys see that? Yes, sort of. Let me see. Circle error? No, okay. Yeah, here it is. I'm sorry, I'm not even watching. Yeah, so they think the cell phone believes that the number is lower. So yeah, they believe that P is less than 92%, 0.92. I like it. You're all right, Laurel. Now's the right time to make mistakes. So which one's that going to be, of course? Oh yeah, so it's going to be the high. So what's the ho? Scheiße, Meise. Oh, no, like, okay. I like it. All right. Okay. Right? Well, let's, how many tail tests will this be? Yes, one tail test, because it's less than, right? It's got a directional, so that's going to be one tail test. Kick ass. All right, second step. How do you check to see if you, is it normal enough? I should do this in different colors. Get over there. Stop it. Hey. All right. Telling inanimate objects to do something. It's a great sign. Yeah, so go ahead and do that real quick. Just to remind you guys, N was 200, right? You put a few facts up there. N is 200. X is 174. And eventually we need to know the alpha was 5%. And of course, that's right where the glare is. I love it. Cooperate. So then NP is going to be 200 times 0.92, right, which is 184. I believe I can do it. Let's see. NQ will be 200 times 0.08, of course, because these together have to make 1. And that's going to be the 16. Let me stop for a minute. Is everybody cool with what I just did? Or let me say this way. Is anybody not okay with what's happening? No. Okay. Everybody's good. All right. So then let's see. Let's go ahead and put the third step up here. Why not? Oh, I don't know. You're okay, Malachi. So we talked about this a while back. Does everybody see Malachi's question down there? I'm not drawing attention to you, Malachi. I'm sure somebody else is probably thinking the same thing. We did that problem a while back where I looked at, remember the flipping a coin problem, and I gave you the handout that had a little Mayan pyramid on the middle of it. And it was normal because there was room for it to go up and down. So the NP makes it go far enough from that wall, because that's the mean. That's actually the mean successes, and NQ is the mean failures, and they have to be far away enough from each wall so there's room to go up and room to come down. Are there more details to that? Yes. Do they fundamentally change what I just said? No, it's almost too nice to believe. It just needs room to go up and come down. If it was less than 5, the highest bar would be too close to one of the walls. They wouldn't have enough room to go up and come down. It wouldn't look normal. That's so beautiful. All right. I don't know, I think it's beautiful, but you know me, I'm a weirdo. So alpha's 0.05. It's normal enough, so we can do it. It's a percentage problem, so as long as it's normal enough, I use z-scores. Alpha 0.05, one cell test. Can you guys look up what the z-score is for that situation? 0.05, one tail. Oh, yummy. Anybody? Has anybody got it? No, sorry. I think you're looking at 0.005. Yeah, it's 1.645, and it's negative. There we go. So it's 1.645, but we're the humans. We see it's down here. It's got to be negative. So the chart's only going to show us positives. Remember, you can get that from the t-score chart, right? At the bottom. So there's my rejection region, right? It's the friend zone. So can you write it? So when I say define the rejection region, draw a picture. Then I say put it into words. So tell me in words what has to happen for me to reject the null. If my Z star is what? Yes, less than. If my Z star is less than negative 1.645, we can reject the null. Support the high. Why is it on the left side of the graph? Because less than. Where must evidence show up to show that it's less than something? It's got to show up over here. Is that right? So, I mean, if you really want to break it down, it's if there's an inequality symbol here, the tail is pointing you in the direction of where the tail is. Less than is going to be down here. I'm going to assume it's okay now. Okay, so let's review what we've done. What the hell are you talking about? What are you allowed to use to talk about it? And then where does evidence start? And now we're on the step of is your sample enough evidence? So now the question is 0.05 came from the problem. Right there. 5% level of significance. Level of significance, another name for alpha. Why do things in math have to have so many names? I don't know. I'm sorry. I apologize. I wasn't around way back. Okay. So now step 4, I want to calculate what Z star is. Why do I put it way over there? Because I don't have any room over here. That's probably why. Okay. So what do I know? So I kind of put it together over there. So I got N is 200. X is 174. So what's P hat? Man, there's a lot of, I didn't really put this up here well. Oh, well, too bad. How do I get P hat? P hat. Yeah, it'll be 174 divided by 200. So it's point, yeah, what'd you say? 7? Yeah, 87, I like it. Right, and then you've got the formula. P hat minus P divided by the square root of all that stuff, right? So now let's just throw it in the old formula. My data, 0.87, minus the supposed middle, 0.92, divided by the square root of 0.92 times 0.08, divided by N, which was 200. Oh my gosh. Okay, get in there. 0.07, 0.035, 10, 0.5 divided by 0.035, 5 divided by 0.350 divided by 3.5, 100 divided by 7. Really? It can't be that. Holy shit, that's way too big. It might be. Is it that big? No, I forgot to square root the damn thing. Damn it. All right, I'm going to stop trying to do it in my head. Shit. So let's see. Any questions on what I've put up here? I'm getting some people saying 261. I'm going to take your word for it because I gave up on trying to do it in my head. I have a calculator, Jeff. Oh, well, I don't care. I'll crowdsource it. Negative 261. Make sure you can get that negative 261. Let me do it just in case. I trust you guys, but not all the way. Just wait till you get that same answer. All right, it's all good. 261. Kick ass. Kicking the ass in. I love it. So if I look back up at my picture, whoop. Have I primed you yet? No. Really? You're going to do it right now, Jeff? Why not? These new markers are funky. Are you going to really do this right now, Jeff? Apparently, I am. You're just going to have to deal with it. There we go. All right, so if I put this negative 261, it's way the hell over there. Ooh, I like you. All right. Right? Oops, somebody's trying to get in. Shit. Can somebody, please, dear God, help me out, find the p-value, please? Yeah, so all you got to do is look up negative 261, and you're done. It's the area and the tail, and since it is a one-tail test, I can just stop there. So I get the p-value is 0.0045. Can't see it, but oh well, it's down there. See. So 0.0045 is my p-value. That's pretty damn small, which corresponds to the fact that our sample got way the hell out there. So that is the probability that we've made, that a sample would show up where it did if the mean was in the right place. So it's much more likely that the mean is in the wrong place because that's such a small probability. Okay. So how did you get what? Sorry, this 0045, Lewis? Yes. Oh, all right. So our Z star is 261. The p-value is the area in the tail that your Z star makes. So you just look up negative 261, right? So negative 261 on the I don't have to show you on the Z-score chart. Yeah. Okay. I like it. So I know that is sitting in the middle of this funky ass problem, but it really is just look up the Z-score, get the area. Good old days. Remember the good old days? You didn't realize how good you had it. All right, so I'm going to erase some of this shit so I have room to write a conclusion. What will my conclusion be? Are we going to reject a null or fail to reject a null? Oh, we reject the hell out of this thing. We're like, get the hell out of here. So let me see what I can take away. I can take away all this shit. Okay. So step 5 will be, we have found sufficient evidence to what? What was our claim? Which one was our claim? It looks like the claim was the H1, right? So we have found sufficient evidence to support the claim. I have to use the language that goes with what the claim is. Never any guess. You don't have to go, it's a coin toss, reject or support. No, just use the right language for the situation. We have found sufficient evidence to support the claim that, what the hell was this thing about? That the percentage, let me see. Oh, the percent of people owning a cell phone is less than 92%. Intriguing. I have no idea what year this is done. See, this book was written about maybe 4 years ago. I think it's probably not that, it's not true anymore, but you never know. There's more people than you think that don't have cell phones, don't have access to internet. Okay. What time? Oh, good. We got some time. How you guys feeling out there? All right, I'll take that as a okay. All right. Any questions on that problem? Oh, I'm okay. Relatively. Right? All right. All right. So I do want to show you something. Let me see if I could do that without erasing everything yet. Where did I put you? Oh, man, what did I do with you? Did I get rid of you? Why would I get rid of you? Damn it. Oh, well, Jeff. I'm having a really weird day today. I'm sorry. I had just looked up a study that I wanted to show you. And now I closed the page or something. That really sucks like a lot. All right, give me a second. Come on. Ho Chi Minh. Let me see. Where did you go? Where did you go? That's not the right one. That's not the right one. Oh, there it is. All right. Ho Chi Minh. There it is. Yay. All right. Stop. Okay, here we go. There's a lot of, all right. Do you guys see this? This is very strange, by the way. I just found this morning. Low incidence of daily active tobacco smoking in patients with symptomatic COVID-19. Now, to be really honest, like I just said, I looked this up right before class started. I haven't even really looked at it. I just want to show you a couple things. You guys all see that, right? The one about, you see all this writing this journal article. Yes, thank you. Notice a couple things. Look at that p-value right there. You will see p-values sprinkled all over the place when you look at any kind of statistical analysis in a journal. Is that p-value small? Hell no. And sure enough, look, the ratios did not significantly differ between the two groups because that p-value is nowhere near small enough. Now, Jeff, where the hell's the other p-values? Give me a second. Let's see. P less than. It's not capital P, Jeff. There it is. Look at that p-value right there. P less than 0.0001. Dude, whatever the hell that is, comorbidities were significantly less frequent in outpatients with hypertension. Whatever the hell that shit means. I like it, Alex. This is the correct time to use surprise Pikachu face. That p-value means that was a very significant finding. It's statistically significant. Is there a chance that the finding itself is wrong? Yeah. It's on the order of this percent chance, right? The point is like what the hell is that? 0.01% chance. Dude, right? So that's why, and okay, here's 0.009. It's bigger than that, but it's still damn small, right? So you'll see p-values all over the place because then we can tell the relative significance of that particular finding. A really small p-value isn't proof that it's right. It's just really good evidence that it's right. Do you guys see that? Do you guys understand? So if you look at a journal article about anything and it uses statistical analysis, you will see p-values sprinkled around because they quickly tell how valid, how significant something is. That's why it's called the level of significance. The alpha is called that. Okay, maybe. All right. I think that's really all I had. I thought there might be more questions, but that's all right. If there aren't more questions, it's fine with me. Let me see. Let me make sure that's all I had. Yeah, because then I'm gonna, as soon as lecture's over, I'm gonna make the quiz active on Canvas. You're gonna want to go get it and do it. The formulas you need are on the quiz itself. There's a front and a back, so just make sure you do both sides. Okay, so any questions, guys? What day is next week's? Oh, I don't know, man. I didn't really say, did I? So let's just say it's next, what is today? So it's next Thursday. Because I really didn't say, did I? Because I'm a jackass. So we officially finished the percentage problem today. So I always like to do the quiz a week after we officially finish talking about something. So that works for me. It sounds good to me too. Thank you. Can you believe that we are remarkably close to final exam time? Well, chapter 10, oh yeah, sure. Let's make chapter 10 extra credit. I got to put a place on Canvas for you to turn it in if you want to. We'll make chapter 10 extra credit. Why not? So you can do it, maybe get some extra credit, or you just don't even have to do chapter 10 homework. Yeah, sure. You're welcome. Don't get used to it. I mean, I might still talk a little bit about chapter 10. I'm probably not going to be able to stop myself, but it won't be due. Okay. I feel like there's something else I wanted to tell you and I can't remember. Too bad. All right. I think I'm done. So let's see. Only assigned homework. Yeah, that's the only one. Yeah. If you do others, that's great for you. I'm not going to look at it. Yeah. So only the one that's assigned. Yeah. All right, guys. Quiz today is, there's 2 hypothesis tests and they're both about the mean. Could they be Z or T problems? Yes, they could be. Quick question for today's work. How do you find the p-value for 2-tail? So again, the first step for a p-value is find the area in the tail your Z star makes. And then if it's a one tail, stop. If it's a two tail, double it. That's all. Does that make sense? Let me see. Okay, I think I got all the questions. All right, guys. That's enough for this craziness. Let's see. Worksheet you're using today. I cannot find it. Oh, shit. Good point. If you're still here, I'm going to activate the quiz, and I might not. I don't think I did. I'm going to put it on the pages. I'm going to put the worksheet we worked on today. I don't know. I don't think I did put it up on Canvas. One tail or two. Again, if there's a direction involved, like the claim is, we think it's less than, we think it's increased, we think it's gone down, we think it's more than it used to be. If there's a direction involved, it's a one-tail test in that direction. If the claim is, I think it changed, I think it ain't that. I think it is that, because then the opposite is not that. Not equal to is two tails. So the only time it's a two-tail test is if H1 is not equal to. How can something be not equal to, bigger or smaller? That's why it's two-tail. Okay, how we doing? All right, I'm not seeing any more questions. So, no, we're not. So if you want to start 10-2, you got to read some. There's 10-2, the Z-score formula gets much bigger because now 10-2 is using two samples instead of just one sample. Oh, yeah. Okay. All right. So I'm going to close down. I'm going to go activate the quiz, and then I'll post that sheet we were working on today. All right. Where's my hand? There it is. Bye. Bye, everybody. Okay. I'm going to shut things down. Bye. Sorry, Alex. You're not going to see who leaves at the end because everybody's leaving right now.